Welcome to my session. My name is Wang from Platform Division. Today, I'd like to talk about Hadoop cluster Align, which has more than 100 petabyte data and more than 2,000 nodes. This is today's agenda. First, I will give a brief introduction of my organization, Data Platform. Then, I will share you the status and problems we had and how we managed to solve them. And last, I'll talk about the next steps of our data infrastructure. Data Platform had the mission to build and provide a governed, self-service data infrastructure so that our users can easily utilize the data. Our daily work is to develop and maintain Line's data infrastructure by providing logging SDK, ingestion pipeline, also known as data chain, query engines such as Presto, Hive, and Spark, also BI tools, and you may have heard of some of them, such as Yanagishima and Oasis. So what does the infrastructure look like? This is a topology of our data infrastructure. As you can see, at the lowest layer, we use machines provided by the infrastructure team and a private cloud called Verda. On the top of that, we use lots of components in Hadoop ecosystem. We set up storage using HDFS and HBase. And we set up computational engine using Yarn and Presto. On the left side is the ingestion pipeline. It has two main components, batch pipeline and a streaming pipeline. We use Scoop for the batch pipeline and Kafka and Flink for the streaming pipeline. On the right side is security and management tools. The platform uses LDAP, Kerberos, and Ranger for authentication, authorization, and auditing. At the highest layer, BI tools and the machine learning platform provide a higher level API for our end users to use. And also, we are using other open source projects such as Elasticsearch, Jude, and Kubernetes to add more possibilities to the platform. I think the infrastructure is very common. So what is special at Line? In my opinion, what differs Line's infrastructure from others is that we handle different data from different domains. It's a multi-tenant platform. Not only service workloads runs on the platform, but also individuals can use this platform to create value. So we developed several tools to support this, such as portal site for registering account, applying permissions, and searching metadata for tables. Now, most of Line services are now utilizing the platform from ingestion pipeline to BI tools. Actually, it's a standard for new service created every day in Line to use this platform. So as a result, Line service grows and our platform grows. Now we have over 2,000 worker nodes that serves as data node, node manager, or Presto worker. Over 100 petabyte data on HDFS. Most of the data is encoded with ORC and compressed with zlib or Snappy. The data is still increasing. Around 390 terabyte new data created in the platform every day. And in my opinion, more importantly, our users use the data more and more. Over 100,000 jobs or queries are now running every day. However, not everything is as bright as I described here. If you zoom into a service, you will find that the data is being processed in the way I showed here. Several types of data flows into the platform via various pipelines and land in different HDFS. And all these HDFS is actually a separate cluster. They have other components such as Resource Manager, Hive, and Ranger. And those blocks are the pipeline solution. Those green blocks are the ingestion pipelines we're providing. All these solutions were created to provide an optimized way for different use cases. For example, Scoop is basically for database dump. Tracking services is for native application. You can add your own event via our SDK. And a web tracking system is basically a web version of tracking service. And data chain allows user to define their protocol buff schema and send to the Kafka, and it will automatically land into the HDFS. However, those pipelines don't share the same specification or the same middleware. So as a result, in order to use the data to do analysis, we have to bring them together. As you may guess, moving data between HDFS is inevitable and happens all the time. And we also need to set up BI tools for every cluster. So here comes the dark side of a large data infrastructure in a large company. Many clusters, lots of batches, and lots of tables in different Hive Metastores. Some tables are duplicated. So data-driven is definitely not easy. From the user's perspective, the UX of the infrastructure is bad. The infrastructure is disconnected, and there are too many components. Our user suffer from asking, what is the best way to bring the data to the platform? Where is the data? Is it in class A or class B? How can I apply the right permission for right data? And also, from my team, from the operation team's perspective, the infrastructure is simply not scalable. Issues pop up regularly. For example, the class A is short of storage, so we need to add more nodes to the cluster. But because it's so large, so the FS image of the cluster is also very large. So we need to clean up. We need to merge some small files or delete some unused old files before we adding more nodes. Or for example, class B is young, is so busy that jobs won't run after being submitted, while class C is idle relatively. So these are the problems we're eager to solve, because remember, our mission is to make data-driven easy at Line. So we want to solve these problems by connecting the infrastructure and make them scalable. But how exactly we can do that? After some discussion, we realized that we need to have one standard for the ingestion pipeline, one set of BI tools, and ideally, only one unified cluster. So even this can be opinionated, but we believe that through this way, our users can focus on their business logic and creating value from the data instead of getting stuck before touching the data. We desperately need this unified cluster. And by the way, we were using Hadoop 2.x, and it will really help if the new cluster is built using Hadoop 3, so that we can utilize the new feature such as erasure coding to deal the increasing data and reduce our infrastructure cost. And also, by unifying those disconnected parts, the operation team can reduce the burden and focus on something like optimization, the query engine. But also, all these goals need to be fulfilled under these user requirements. We are an internal system, but we have users. We always put our users first. So we don't want to bring too many breaking changes to confuse the users. Also, jobs requiring higher SLA. such as recommendation engine, are also running on the clusters. So minimum downtime is also required. And we don't want to, actually, we cannot force a migration schedule to the users, because at Line, we have different products. Different products have different plans. So we have to let them migrate at their own pace. And also, you always keep cost effectiveness in mind. No reduce, and hopefully we can upgrade Hadoop in place. If you are in the previous session, Nick talked about security. The security and user experience was often a trade-off. But we are greedy here, so we won't compromise. We don't want to take risks or bring any security concerns to the platform. So after setting the goals, we had our first meeting and came up with some naive solutions. These are two of the solutions. And I think there are some solutions that first came into our mind because they are very simple. For example, we could create a new cluster and then move everything there. Or we could pick up the biggest cluster and merge the smaller ones there. These solutions are definitely possible, but we are not satisfied with them. And let's see why. This one, the create and move one. It is the simplest one, just like writing new code without technical debt. It's way easier than refactoring legacy code. And by using this method, we can create a clean Hadoop 3 cluster without any problem. But it also the most troublesome one, especially for our user, because all the environments will change. It also requires a very long migration period. Our team needs to spend a long time checking the progress. And in the worst case, we need to double the nodes we have. That means 2,000 more nodes need to be purchased. It is the opposite of cost effectiveness. And the second one, the merge the biggest solution one. It costs less time and budget compared to the previous one. But unfortunately, the biggest cluster by size is not secured by kernels. And remember, we don't want to compromise security. Also, we had not one, but two relatively big clusters that users use heavily. It will be very hard to decide which will be the unified cluster to be migrated. And after all, even we managed to pick up one cluster and finish merging, we still need to face a problem that to upgrade the Hadoop. So we wonder, can we do better? At that time, we noticed two features shipped with Hadoop. One is HDFS Federation. I wonder how many of you are using HDFS Federation in your production environment? Okay, one, not bad. And how many of you heard of this feature? Okay, more. Cool. As you may know, it's not a new feature. And it was designed to scale Hadoop by allow Hadoop use multiple independent name nodes or name services in this context. Here, the data nodes are used as a common storage for blocks by all the name nodes. Each name node will register itself with all name nodes in the cluster, and all the RPC will be independently executed. The other one is ViewFS. It's a client-side routing table. Basically, client can use ViewFS and mount table to figure out which name node or namespaces it wants to access. Notice here is that using HDFS Federation and ViewFS doesn't mean that the data is managed in one place. We cannot move data between namespaces easily. This CP is usually required. But based on these two features, we thought we should able to create an ideal solution. These blocks represent existing Hadoop cluster line. We pick up the two biggest and the most used one I just mentioned. Notice here, those smaller ones usually have less than 100 nodes. And those two bigger one has 1,200 nodes and one has 600 nodes. Then we merge the data and basically move everything from the smaller one to those bigger one. Then we create a new cluster using Hadoop 3. At this time, we don't merge those two big cluster to the new one. Instead, we connect those two cluster with a unified cluster using HDFS Federation. Based on this solution, we can draft our roadmap. First, we want to clean up all those small cluster, and we connect HDFS on those basic major components. And last, we can sync the DDLs in Hive Metastore and clean up the data. And finally, we can remove old cluster. The cleanup is very simple and not interesting, so I skip it and talk more about the other three. I redraw the graph of the two major clusters with more details. Each cluster has name node, resource manager. Each worker node has both data node and node manager in it. Notice we both use HDP 2.6, but only one is guarded by Kerberos. Then we create the seed cluster using Apache Hadoop 3.1 and also secured by Kerberos. Here, we used a new KDC for the new cluster because eventually we want to remove all the components in the old cluster. KDC is also included. I will talk later why we chose Apache and build our own release instead of continuing using HDP. After setting up the seed cluster, we can transfer HDP 2.6 to Apache Hadoop 3.1 by decommission the old nodes, install 3.1 binary, and serve service in. Here, the data node will serve all three clusters name node using HDFS Federation, but node manager will only serve the new resource manager. So the number in name node won't change. It's still 1,200 and 600, but the nodes in resource manager will become less and less. In the meantime, at this period, our user who wants to migrate to the new cluster can get started. We use 300 nodes for a new cluster. It's because that we want to provide a fairly large scale for our users to migrate, and also we want to accelerate the HDFS rebalancing when moving the data. It also allows the user to have a flexible migration plan because we can control the pace of moving nodes. So basically here, the N and M is controllable. We can monitoring the whole system and decide how many nodes we want to move. After all nodes being moved to the seed cluster, the old resource managers are not needed anymore. And at this time, all the worker nodes will become 3.1, and all our users are using Yarn 3.1 only. Then we can sync the DDL and move the data from old cluster to new cluster, and eventually remove the old name node. So this plan sounds great, but devil's in the details. After some tests, we found that HDFS Federation have requirements that we don't meet. First, the same cluster ID, also known as CID, is required. You're probably not familiar with CID because quote from the official documentation, a cluster ID is identifier is used to identify all the nodes in the cluster. This ID should be used for formatting the other name nodes into the cluster. So basically, you will only use CID when you format a new FS image. But unfortunately, our old cluster were created by different teams at different time. So CID is not the same. Second, the same security level. When Kerberos is enabled, the same ROM must be the same. The last requirement is the same RPC version. And this one, I think, is very straightforward because those components need to talk to each other. They need to have the same protocol schema. And because these difficulties are expected, so we chose vanilla Hadoop at the first place. And let's see how we solve those problems. The CID. Actually, since we didn't find any information about how to change CID, we were worried about that our ideal solution is still feasible. But after some try and error attempts, we found CID can be modified. Actually, this part is very unique and interesting, but I won't explain much here. So if you are interested, please feel free to ask me later. Anyway, we managed to change the CID for all our clusters. Then, speaking of the requirement of the same Kerberos ROM, name node assumes that ROM of data node is the same as itself, and then use it to check if each data node is legal for service authorization. But since we are already set up to KDC and set up the cross-ROM trust, the comparison is not necessary and can be simplified to only compare the primary of the principal. The primary of the principal is actually the first part of the principal, if you are familiar with it. And then we fix the RPC part. Here is the storage type in block token identifier. Storage type is a feature I think is introduced since 2.4, but there's no field in block token identifier until 3.0. In our environment, the client will ask name node of 2.7 to get the block token identifier and pass it to data node, which is 3.1. The data node will fail to deserialize the token, and the client won't get the block. Since we are not using storage type in our production environment, we can safely add default field to the class and also implement the serialization and deserialization logic. After solving those three problems, we can bring the worker node together, and the infrastructure looks like this. Data nodes serve multiple name services. And if you list the directory in the data node, you will find several block pools as expected. Actually, we have more than 3. We have 6 name services in our production. But we still need to focus on the young part. HDFS is being connected. So how to merge the young? Here, multiple clients will use a single young, but each client has its own configuration. Those configurations are different. So some of you may think that young is just a runtime, so it should be HDFS agnostic. But actually, it ties up with HDFS. It's a subproject of Hadoop. So let's see why. In a secure cluster, KDC is in charge of authentication. Every component needs to authenticate via KDC using TGT, the ticket granting ticket. And KDC will become the bottleneck when the components increase. So dedication token is introduced to solve the performance issue. Usually, HDFS, KMS, and Young will use this mechanism. Here, we only talk about HDFS dedication token. With HDFS dedication token, client will get it from a name node defined by FS default FS. Then it will submit the application with the dedication token to Young. And once Young accepted the application, it will access the data in HDFS with this token and do the computation. Typically, the configuration, the FS, default FS of Young and clients are the same. But in our case, we have a new configuration for Young, which uses ViewFS. But clients still use old configuration for backward compatibility. As a result, the client will only get the dedication token from the old cluster. But remember, we use a mapping table in Node Manager in Young. So the user directory and the log directory is not in the old cluster, it's in the new cluster. So Young will create temporary files in the user directory, and if log aggregation is enabled, the log will also be written by Node Manager. So of course, those actions will fail because lack of the dedication token, and the application itself will eventually fail as well. So we need to let the client take the token from the new namespace before submitting the application. Thanks to the community, actually, Spark, Test, and MapReduce already have this configuration to do that. User can add those configuration to tell the client specifically what cluster they want to access besides the FS default FS. So problem solved. Young worked. For users, uses Hive Server 2, which also is a solution we provide. We change the configuration for them so that those users don't need to know which Young they are actually using. And for Sparker users, they only need to add one single line of configuration and change the Young's endpoint so they are good to go. Also, as I said earlier, we can keep this structure for a long time so our user don't need to hurry to migrate. At last, I'd like to share some ongoing work for unifying the Hive Metastore. Since our managed pipeline service controls the life cycle of the raw data, we can add a common logic to the system to sync DDL or data automatically. For user-generated data, we use a Hive hook to collect changes and sync to the new Metastore. But because the sync of the Hive Metastore will not finish soon, we provide Presto with 3 Hive catalogs so that our user can analyze data across different clusters in the transition period. Of course, since we are not using HDFS Hadoop distribution such as HDP anymore, we've also solved encountered and solved a lot of other problems, along with the major problems of HDFS and Yarn. Mainly, they are caused by the premature Hadoop 3.x support and Kerberos. For example, our pipeline depends on Flink, but Flink doesn't support VUFS very well. We found bucketing syncing won't truncate file when using VUFS paths, so the job cannot restart with a save point. Another example is that because our federation connects insecure name node and secure data node at the same time, it is possible that web HDFS client will access secure data node and retrieve data managed by an insecure name node. In this case, the data node will refuse the client because of the lack of dedication token. It's a bug, but I think it only happens in our environment. And all these problems are fixed using our own patch. And some of them now is merged to the upstream and released. For example, in order to control user permission better, my colleague added Hive Metastore impersonation feature, which is long missing in Presto. And now it's released and everyone can use this feature. At last, I want to give a simple summary of what we have achieved so far. By using this method, we successfully merge our disconnected cluster together and upgrade the major version at the same time. We believe through this method, we keep the user impact minimum. The merge of HDFS and Yarn are almost user unaware. And the user can take their time to migrate their own workloads. As a team whose mission to provide data infrastructure, we clean up the technical debt and had a good start of the next generation platform. Our trip still goes on. We will continue to invest in big data infrastructure and contribute to the community. We are hiring. Actually, we had a booth noon and not many people came. So please talk me later about our department, about the technical stack we are using. And thank you again for coming to my session. Have a nice day.